Welcome to this explainer. Imagine, just for a second, the sheer volume of data pulsing across the globe right this very second. It's mind-blowing, right? We're living in an era where data infrastructure isn't just some back-end necessity anymore, it is literally the heartbeat of modern technology. Today, we're stepping into the massive, high-stakes data ecosystem of 2026 to explore the top 10 fastest and most widely used databases on the planet. So get ready, because we're going to unpack the actual engines that make our digital world run.
Okay, let's dive into this. What exactly is powering the real-time tech of 2026? Well, we're seeing an absolute explosion in artificial intelligence, specifically things like vector search and retrieval-augmented generation. Then you add to that the massive demands of real-time analytics, ultra-high traffic mobile apps, and literally millions of connected IoT devices. All of this puts immense, completely unprecedented pressure on modern architectures. Speed, and by that I mean ultra-low latency combined with massive throughput, is no longer a luxury. It's a strict requirement if you want to survive.
Here's our Architect's Toolkit roadmap for today. We'll be covering the data landscape of 2026, the relational powerhouses, our need for speed and flexibility, the analytics heavyweights, and finally, the polyglot persistence strategy. Let's get right into it.
Section 1. The data landscape of 2026.
To truly grasp how these tools fit together, we've kind of got to treat the database ecosystem like heavy machinery. I mean, you wouldn't use a sports car to haul a shipping container, right? And you definitely wouldn't use a massive dump truck to win a drag race. The exact same logic applies to data. Just look at the key trends shaping the terrain this machinery has to navigate. Performance and proven deployment are absolutely king. First up, multi-model and vector support is everywhere. If you're building AI apps today, your database simply has to handle vector similarity natively. Second, we're living in a real-time everything world that demands sub-second analytics. Third, cloud-native and serverless architectures are giving us that crucial elastic scaling, which really takes the operational burden off your team. We're also seeing a huge rise in hybrid architectures, plus a fascinating surge in open-source forks. Think Valkey for Redis and ScyllaDB for Cassandra.
This curated top 10 list perfectly illustrates the landscape. It's based on the June 2026 DB Engine's rankings, and it's cross-referenced with real-world production benchmarks. It beautifully balances widespread adoption with raw brute force performance. As we break these down by category, you're going to see a real mix of traditional heavyweights and specialized speed demons.
Section 2. The relational powerhouses.
Now we're shifting gears first into the foundational engines of the data world. These are the bedrock technologies that guarantee consistency, structure, and reliability. Now what's really interesting about this comparison is the contrast between our first two giants. Postgres holds that top spot because it's just such a versatile multi-model leader. Its JSONB performance is absolutely phenomenal, but the real killer feature? That's the PG Vector extension for AI. It's exactly why titans like Instagram and Spotify trust it. Then on the flip side, MySQL ranks right up there at number 3. This is your web-scale workhorse for straightforward, read-heavy transactional workloads. If you're running e-commerce or massive content management systems, MySQL just delivers incredibly high throughput, optimized performance day in and day out.
But what if you don't actually need a massive server cluster? Well, enter SQLite. Ranked 7th overall, this little engine is arguably the most ubiquitous database on the planet. It's basically the ultimate everyday pocket tool, because it provides zero overhead, direct local file input and output without needing a dedicated server process. It's quietly powering billions of iOS and Android apps, desktop applications like VS Code, and tons of edge computing devices. It's tiny, it's free, and it is just rock solid.
Rounding out our list at number 10 is Oracle Database. Now, while it might sit at the bottom of this specific top 10 list, as the whole industry shifts toward more agile open-source tools, make no mistake, it remains the ultimate enterprise powerhouse. It's the absolute backbone of global banking, massive telecommunications, and heavy-duty government systems. When you properly tune it, its performance for mission-critical workloads is genuinely staggering. Of course, all those sophisticated, robust features do come with some famously expensive licensing and highly complex administration. But hey, for the largest enterprises in the world, that trade-off is absolutely worth it.
Section 3. Need for speed and flexibility.
Let's accelerate the pacing here a bit, because we're moving away from those structural foundations and looking at the specialized vehicles of the tech stack built for pure, unadulterated speed. Sub-millisecond. That is the latency benchmark we're talking about with Redis and its wildly popular open-source fork, Valkey. Sitting high up at number 2, it is the de facto speed layer of modern architecture. Because it operates entirely in memory, it can handle literally millions of operations per second on just modest hardware. Honestly, if you're interacting with a real-time leaderboard, caching a web page, or sending instant chat messages, you're experiencing the blistering speed of Redis right behind the scenes.
Alongside speed, modern apps desperately need flexibility and scale. And here we have two totally different approaches to solving that problem. MongoDB, ranking at number 5, is the reigning champion of document databases. Its flexible schema is an absolute dream for developers working with rapidly changing data structures. Think mobile backends and dynamic product catalogs. Conversely, take a look at Apache Cassandra at number 10. Cassandra is a wide column store built for extreme linear scalability. When you're dealing with massive, high-volume write throughput, like a flood of IoT sensor data or the globally distributed systems over at Netflix and Apple, Cassandra ensures there's absolutely no single point of failure.
Section 4. The analytics heavyweights.
Processing real-time transactions is one thing, but to actually make sense of all that information, you need to be able to query billions of rows of data in sub-seconds. That's the reality brought to the table by ClickHouse, sitting comfortably at number 6. It's a rapidly rising columnar OLAP database. That means it stores data by columns rather than rows, which allows for exceptional compression and just blinding analytic speed. Massive companies like Uber and Cloudflare are leveraging ClickHouse to power their real-time business intelligence and observability dashboards at an unbelievable scale.
Rounding out our analytics and search capabilities, we have Elasticsearch and Snowflake. Elasticsearch, ranked 12th, is the undisputed core of logging and observability. It's the engine that allows you to do near real-time full-text and vector searches across huge volumes of log and document data. Snowflake, on the other hand, sits at number 9 as a true leader in cloud data warehousing. By brilliantly separating storage and compute, Snowflake gives data science teams this instant elasticity. They can run complex ad hoc queries on petabytes of data without skipping a beat.
Section 5. The Polyglot Persistence Strategy.
We've looked at all these incredible engines, but here is the ultimate realization of 2026. There is no single winner. Instead, the absolute best architects use something called polyglot persistence. Now, this isn't just a trendy buzzword, it's a vital strategic practice. So the crucial point is intentionally combining 2 to 4 different database technologies within a single application. You stop trying to force one database to do everything poorly, and instead you use highly specialized tools to maximize both developer productivity and raw speed.
Let's walk through exactly how an architect logically builds that matchmaking process. Step 1. Critically identify your primary workload. Are you building a transactional web app, or are you managing extreme global scale? Step 2. You choose your primary relational or document store based on that. Maybe it's PostgreSQL for its AI versatility, or MySQL for massive volume. And then step 3. This is where the magic really happens. You bolt on specialized layers. You might add Redis to handle ultra-low latency caching, and then maybe pipe your logs straight into Elasticsearch for real-time monitoring. The whole system becomes so much greater than the sum of its parts. The source material summarizes the state of the industry perfectly. Quote, "The database world in 2026 rewards architectures that prioritize both raw speed and developer productivity while scaling reliably. Postgres' continued rise shows that versatility and performance can coexist beautifully." That really is the ultimate takeaway here. You no longer have to compromise on performance to get a truly great developer experience.
Section 6. Discover more. Let's move to and see how this builds into our final thoughts.
Take a hard look at the infrastructure your team is running right now. Knowing the distinct power, speed, and specialization of each of these incredible tools, ask yourself, are you really using the right heavy machinery for the job? How will you combine these engines to build your next massive application, ensuring it actually survives the real-time demands of the future?
Thank you so much for joining me for this explainer on the heavyweights of the data world. We really hope this deep dive has given you some great clarity on the incredible engines driving modern tech. For more, visit our website, Ferris Solution. Keep building, keep innovating, and we'll see you next time.